Hi guys, welcome to this section where we're going to be making bowling pins and a bowling ball. What are we going to cover?
Well, more complex meshes. The whole idea here is that we step outside of our comfort zone again. You just got used to box modelling. Now we're going to introduce you to curvy things like bowling pins. How are they going to make a bowling pin, Mikey?
Well, in this module, we're actually going to suck in some reference material from a picture. So we're going to bring that into Blender and use that to trace our model.
So reference material, real-world reference material, that is a pretty handy technique. And then we're going to move on from there and look at shading, a little bit of real-world shading. Just basic stuff. We're just going to put a red stripe or whatever colour stripe you want around that bowling pin and show you how to make different parts of your model appear different for the first time. So we really want you to do that. In fact, maybe, Mikey, you can stress how much we want them to customise.
Yes, you could make anything. Make it your gnome.
Your gnome? Make
yes.
it your gnome.
Make the bowling pins gnomes.
Ah, it was an intentional slip of the tongue. You're going to make gnomes. Make it. You see what he did there? He's really funny, this guy. Make it your own. Make it your gnome, garden gnome. You've got to make garden gnomes now.
I think they understand.
I think they've got it. Right. Okay. So look, another thing that's really important is we're going to be talking about the whole workflow in this section. So I'm going to show you at the end how to export your model and then, just as an example, how to import it into another package. And I'm going to use Unity as the example. You don't need to follow along. You don't need to download Unity. It's a very big package. If you've already got it, sure. But you'll be able to see the impact of the way that you build your model in Blender and how that manifests itself over in a different package. Okay, and there are things to consider like the scale of the model, like the rotation of the model.
The normals of the model.
The normals, back to those old chestnuts.
Yes.
And also the way that your hierarchy of objects is arranged and named. So all of that type of stuff is going to impact how it's exported. And it's important to begin with the end in mind. Good old Stephen Covey, or even Covey, will tell you that. So that's what we're going to be doing.
Yep, and always remember to enjoy yourself throughout this entire section. And if you do have questions, ask, and make sure you post your results in the discussion so we can see how you're getting on.
Hey guys, and welcome to this video. We're going to talk a little bit about the lean production process. Start getting you thinking about your workflow, right, Mikey?
Yes. Now, I've struggled with the concept of lean production because that's not generally how we're taught to do things. We do everything almost in our lives in batches. And when you switch over to a lean production, it actually makes things a hell of a lot easier. But it takes a while to get your head round. And Ben's going to explain that a bit more in detail now.
Yeah, so what's lean about? Really, it's about three things. Lean is about delivering value to the customer, i.e. something that the customer will pay for, the end customer. So say you are making, well, bowling pins and a bowling ball in this case,
yeah,
and you're handing it over to a game developer.
Yes.
Eventually, there's going to be a game made, and somebody on the App Store is going to be flicking through and deciding whether they're going to buy that game. And if what you're about to do isn't going to add to that end experience, it's not value. So that's what value is. It's about delivering something they'll pay for.
Yep. And in the case that that's exactly how we're making this course. We output something to you guys as quickly as possible and let you guys give us the feedback as quickly as possible. And then you want to employ that basically in your modelling. So you want to make sure you get to the end result as quickly as possible, find out all the problems you're going to have, and then jump back again and reiterate and make them better. It's all about a feedback cycle, making sure that you get that feedback quickly and improve your model or improve the course or whatever you're working on as quickly as possible.
Yeah, so feedback is key. Now, Mikey says deliver the end result. Now, we need to be careful about that. It's deliver a first version of the end result.
Yes.
That's the whole point here. And like sometimes maybe you've seen an image load on the web and it just really fuzzy and then it gets sharper and sharper. That's kind of like lean because it's giving you an impression of the entire thing. Very early on, you can go, I am or I am not interested in waiting for the rest of this image. And that's a bit like your bowling pins or your bowling ball. What you want to do is mock something super simple up, get it through to your game developer, for example, and then get their feedback. They might go, oh, the pin's got too many polygons for my colliders, or the ball doesn't look right, or the axis is wrong, or the handedness is wrong, or something. So get a really basic version and then keep iterating. So in this video, we want to help you to understand that lean is not about pre-production, production, and post-production. We want you to imagine that you're creating these bowling assets, or get these assets for a bowling game, computer game.
Yep.
We want to help you understand how many iterations you need to do.
Yes, it's very important because it's very easy to keep going and keep going and keep going and searching for that 100% perfect. And that is an unobtainable goal. What we really want is that 80-20 rule. You've probably heard of that. We want to get to that core 20% that is going to produce 80% of our outcome.
Absolutely. So this lean production method is a way of discovering your first base is to discover the 20% of work that you need to do, just 20% of all the work you could do, that's going to deliver 80% of the value. That might well be you're a perfectionist and that 80% is not good enough, and that's fine. But then we'll work out what the 30% is that gives you 95% of the value, and so on. So,
yeah, diminishing returns can rear their ugly head very quickly whenever you're doing anything like 3D modelling.
So in the slides for the course, we've given you a little bit of information here. Let's just define lean again. This is a summary of Wikipedia. It says that it eliminates waste created through overburden or uneven production process. Let's talk about that for a second. It's all about not wasting your time or not wasting any input before you get stuff to the customer.
So I've already produced some bowling pins and a bowling ball for Ben and his Unity course that he's working on. And the first thing I did was I went away and produced a wonderful, great big high definition bowling pin. And we soon found we were running into problems. Now, I spent a lot of time getting that, in my mind, that bowling pin perfect for Ben. But in fact, it wasn't perfect for Ben because I didn't understand the constraints he was under with what he was doing. So then we very quickly went into a series of rapid iterations to get to exactly what Ben wanted. Absolutely. And that was important because otherwise it's wasting my time generating all that stuff that's of no value to Ben and ultimately you guys if you're taking the course. But ultimately I'm also wasting Ben time. So he's sat there waiting for an asset. So it goes both ways. It's about eliminating both sides of the waste.
So the whole point is to really plan your work, right? So we want to eliminate waste. We want to maximize the flow of value, i.e. something that the customer will pay for. And ultimately, it's about getting the highest possible quality. It's about finding a way of making that thing that is at the highest possible quality.
Now, I must stress at this point, it is a learning journey to get to a lean production. And you are going to find that it's difficult from time to time to adjust to that because you'll want to achieve the best results you possibly can. However, we urge you to iterate as many possible times that you can. In fact, there's a good fable about this, and Ben tells it incredibly well.
Well, I'll summarise it here, but there's a fable. It may be an apocryphal story, but the idea is that a teacher of a pottery class says, guys, I'm going to divide the class in two this term. One half of you are going to be rewarded with a prize at the end of the term for those who have made the most, the person who has made the most pottery. We're just going to put it on a scale, see who's made the most. On the other side of the class, we are going to reward the person who makes the best piece of pottery. And guess what? At the end of the term, it was both the person that made the most pottery that also made the single best piece of pottery, which is kind of against what you'd think. You'd have thought the person who labours over one supposed masterpiece would produce the best thing, but actually the process of iterating and just doing more stuff, throwing more at the wall, and maybe more sticks. So that's the concept here, is get busy, get active, and get the entire pipeline done. We're going to be showing you that the bowling pin that you create, for example, in a game engine needs a very different type of mesh for collision detection, and that mesh has some constraints on it. It must be convex, and it must have less than 255 or less polygons. And that is very, very different to the visual mesh that you're going to create. And in future sections, we'll also be talking about things like normal maps or bump maps and how this ties into the process. So please get it through the whole pipeline. You know we showed you about handedness and about left and right-hand coordinate systems, and also about what's up, Y or Z. All of that you want, and scales. That's the other thing. Get all that out early. The game guy may go, the scale's all wrong, it's pointing in the wrong direction.
Yes, and obviously with a bowling pin, that's not going to be an arduous task to rotate it, but if you just produced 1,000 assets for something and they're all the wrong way up, that's not going to annoy, it's going to annoy everybody in the production process. However, if you were running a lean production, the first asset they received, they could have given you that feedback and no more problem further on.
So in your mind, remember the progressive JPEG. You get to that website, you get a fuzzy image, and then it gets sharper and sharper and sharper. Even Netflix does that when you watch it. And the thing is that you can make a decision about the complete product and say, yes, I do or I don't want it in that form. You can change the film before you have to wait for that high def stream to buffer. You can change the image before you wait for the full thing to download. The same thing, get your models to the end user as quickly as possible, and then improve and improve and improve.
And that's where the box modelling we've already covered comes in. That's literally your placeholder asset that you would move about to see whether it fits in your scene, to see whether it's the right size, scale, upright, and everything else. So that's why that's core to getting that simple model out there straight away.
And also, all the unexpected things won't catch you out either. There can be a million things you can imagine that may be going wrong to do with lighting or reflections or scale or rotation. It goes on and on and on. And by progressively building up the entire pipeline and not just working on your model in isolation, but delivering it out, rendering it, post-processing, the whole lot, then you're going to avoid those mistakes. Another brief example we gave when chatting about it earlier was maybe you've been tasked to just do a close-in, realistic thing of somebody's face, and maybe you missed the part of the brief that they're going to crop everything but their eyes, and you spent 3 days modelling an ear, and it's not going to appear as part of the scene. Or maybe something that's reflecting in the eyes is very important that you've included in your scene, so it matches some real footage. Or it goes on. The point is, iterate like they do in the films, and you'll be golden.
Excellent. Well, let's get on with some modelling.
Let's do it.
Welcome back. Knowing your topic and specification. So in this video, we'll be understanding your subject, planning your model, and knowing the importance of research. So, challenge. Let's do some research. Pause the video now, go and search for bowling pictures, watch some videos if necessary, and look up the specifications of the ball and pins. Okay, welcome back. So how did you get on with that challenge? Let's go off and do some research ourselves now, so you can see what I would be doing. Okay, so I have Googled a picture of a bowling ball. So we've got lots of pictures here of bowling balls. Now, one of the things that's incredibly important is I would have probably drawn a bowling ball like this black one here. Now, as you can see, a real bowling ball has 2 holes really close together, and the third one, for your thumb, much further away. Now, I can almost guarantee that if I had asked you to model a bowling ball without any reference material, you'd have probably put that third hole for your thumb too close, or the 2 finger holes too far apart. Equally, when I was looking for a bowling pin, you can see there are loads of different ones that you could pick. And will you be using one of these for our reference material in a bit, so we can model a pin accurately? And another thing I spotted when going down was the actual configuration of the pins. So later on, when we come to laying out the pins themselves, we can see here we have an overview. They're 12 inches apart from one another in any direction, which is great. And this line here, C, yeah, that's 36. So it's an equilateral triangle of 36, 36, and 36, and each one is 12 inches apart, which is great because that means we now know how to set up those pins in our scene later on. Okay, so that's enough research for now. Let's crack on and start doing some modelling. Hello and welcome to Blender Model Scale. In this video, we will discuss how Blender has its own units called Blender units, and that's abbreviated to BU. Now, these Blender units themselves can be defined as several other units as well, so millimeters, inches, centimeters, etc. We're not going to use that in this particular section because it can have some quite severe knock-on effects if you don't realize the scale your model is set to, and you're either exporting it or indeed bringing it into another scene. You think it's one size, you bring it across. That's something we'll leave until a later section. Now, Blender units, the scale works really well between 0.01 and 100 Blender units. Now, it doesn't matter what those units are, whether they're millimeters or kilometers, that's the scale within Blender that we will be working to and what they apply to. Now, a rule of thumb is use that grid floor as a stage, and we'll have a look at that in closer detail. And selecting an order of magnitude suitable for the level of detail. So if you were modelling the planet Earth, but you were modelling a solar system, you wouldn't need to perhaps have it that big at all. If you were on the ground and you were modelling a mountain, you'd have far more detail. And if you're on a desk and you've got loads of things close up to the viewer, of course, you're going to have lots more detail there as well. So let's go explore Blender units now and the way that Blender scales things over in Blender. Hey, so now we're over in Blender, and I'm Michael from the future, did you know? Yes, I've come back to this lecture to give you some better information, and you may notice I'm now on a Windows computer. It doesn't matter, this just shows you the uniformity of Blender's interface across multiple platforms. So some things may be ever so slightly different, but don't worry, that won't change what we're doing here. So zooming in and out. Now you can see as we're zooming backwards and forwards, we've got a scale. We've got this grid floor on the ground. Now this grid floor can be controlled if I press the N key to open up the properties panel and scroll down. There is an option under display for the grid floor. You can turn it off if you like, or turn it back on. There we go, on and off. You can also change the red and green axes, and you can even put the blue one on as well if you wanted to. I'm going to leave it as default, but you can see here we can change the whole scale of this as well if we wanted to. Now I'm not going to touch that. I leave that as default all the time just to give me perspective of how large my model actually is. So let's take the real extreme. Let's go ahead and select our cube and scale it all the way down. So we're going to scale to 0.001. If we, I completely mashed the keypad here. If we look down in the lower left, we can see the scale that's being applied. Now I can't see that very easily at the moment. If we try and scale to it, we'll run out of zoom. You'll do this lots during the first time you use Blender. You can't zoom any further, it seems to run out. Now we can use the shortcut here, and we'll discuss this later as well. Under View, if I get my mouse in the right place, under View, we can view selected. And we can see the number pad full stop, if you've got one, can be used as well. So if I go ahead and press that, we zoom all the way in. Now we're able to zoom. It's reset our zoom so we can zoom in and out accordingly. Now you see the issue here, there's clipping. Now we can change this as well. We can change at what point the camera clips the object, but at the moment it's just too close to the camera. Now, that is a problem because you can't model effectively if you can't get close enough. And this is what I mean by if something is too small, then you can't work on it. Less than this, and it's just useless as far as I'm concerned. I'm going to undo that to bring the cube back up to real size, or the default size rather. And now I'm going to scale it this time by 100. Of course, I could have scaled it by 10,000. Now let's zoom out. And you see here we get zooming issues at this range as well. And again, we can change the clipping. But if you've got a scene this big, I mean, this is a huge cube. It's 200 Blender units across. So it's a pretty large cube. Now you can see the surfaces inside here. Now you may want to make an environment on those walls, for instance, if you wanted to. That's one example of making something this big. But you can see that if you were making a model much bigger, you start getting the clipping issue, but on the other end, rather than on the low end, on the high end. Now you can change that clipping issue on the display once again. If we scroll up, in the properties panel, if we scroll up just a little and go to the view, we can actually change the clipping distance, the end and the start. But once again, I wouldn't bother playing with those unless you really, really needed to. But you see, we can bring that back into view now by increasing that end scale. I'm going to set it back to 1,000. And that itself will control the clipping. But that means you're going to go outside, not sort of like the normal operation range of Blender. Okay, so there's one final thing to go over when it comes to Blender scale. This cube here is 2 Blender units by 2 Blender units by 2 Blender units in size. Now, what does a Blender unit really mean? Well, it can mean anything. Okay, it can mean a centimeter, it can mean a meter, it can mean a kilometer, it can mean lots of different things. In fact, we can actually pick what it means. So if we go over to the properties window on the right hand side, if we go to the third tab along the scene properties, we get an option to switch the units. Now notice at the moment the length says none. Okay, so if we switch this, it currently says meters. Yours may say something else if you played with this in the past. If we switch it to centimeters, we can see that the unit scale, everything's scaled down to 100th of what it was before. Now, if we have a look at the 3D editor view, and now we zoom out, we see that the grid floor is disappearing. So we've gone 100th of the size, which sounds great. But hang on a minute, we've now made this grid floor huge. And we can pick loads of other things as well. We can do feet, inches, kilometers. Also notice that all of these dimensions, all of the distances have all changed to meters. So we've got 2 centimeters at the top here. This is 1 millimeter to 10 meters. The location is 0, 0, 0, and gravity now has meters per second on it. If we go back to the length here and switch it to none, we just see we get arbitrary scales. Now, by default, Blender units are kind of 1 meter. It's as straightforward as that, and we can see it sits in the scene. But equally, you could have worked in feet. But the units don't really matter. I know that's difficult to get across. Now, they certainly do matter if you're putting things into the real world. You don't want, say you were 3D printing something and you accidentally made it a kilometer long. That'd be a huge 3D printer. However, when it comes to working in Blender itself, changing the units can cause a bit of a problem. Because if you start mixing and matching units across different projects, when you go and import them, they will look different. They will be different sizes, and you won't be able to homogenize, bring all your components together easily if you've made them at different scales. Now, that said, if you do choose to change the units, be aware that they're under this tab and you can change them back to meters or whatever you want, or indeed just go to the length and set it to none again, and we see all these change as well. We see that the lens has gone from 35 millimeters back to 35. So it's one of those things that I'm not going to delve into deep details within the rest of the course. I'm going to leave mine as just Blender units, and the reason for that is so we don't get any confusion. If you change it and then start importing things into a different model or appending models together, it can be very confusing if you've got nothing noted down of where the scale is. Now, with that in mind, noting things down, just want to give you a very quick tip. We can change one of these windows or create a new one. I'm going to create a new one from the properties panel and just drag it down. And I'm going to switch the type of that window over to a text editor. Now, once you've got a text editor open, you can actually type in this field. Now, you may wonder why you can't type anything in. Well, like most things in Blender, you need to click New first. I'm just going to bring this out so we can see what's going on. Notice we've got New here. If we go ahead and click on New, now we can type, which is excellent. However, what you should know is if your cursor drifts elsewhere onto a different window, you're not going to be able to type anymore. So do bear that in mind, is as you're typing away, if you nudge the cursor, as in your mouse cursor, to somewhere else that's not over this window, you will cease to type. Of course, you can save that along with your project and make any notes as you're going along, which may or may not be useful depending on the project you're working on. It's challenge time! I'd like you to now think of the order of magnitude that you'll be working with. So I've filled in part of this chart so you can get an idea of what we're working to. Our first column here, the object, is a real-world object, and I've put its real size in. Now, obviously, you will find ants and grasshoppers that deviate from these sizes. I'm 1.6 meters tall, so I've based my human on that. Now, that's actually quite short in some cases. So, you know, these are just general real sizes, not exact. And I've gone through the motions of which way am I scaling it? Am I scaling it up? Am I going to keep the scale kind of the same, so 1 meter equals 1 Blender unit, or am I going to reduce the scale? Pause the video now, go through this list, give it some thought about how big you would make this object on the left in Blender. Okay, welcome back. This is how I would do the scaling myself. So let's start from the car. The car's about 4 meters long in general, and I keep the scaling the same in Blender. There's plenty of scope to do millimeter level stuff all the way up to the meter scale there. So that's absolutely fine. We can keep that the same. And similarly with house, you can keep that the same as well. 10 Blender units, 10 meters, absolutely fine. Obviously, some houses are smaller than that, and some can be much bigger, but that's absolutely fine. Next is an oil tanker. Now, we start to get into the realms of very large objects here. Now, a real size oil tanker could be in 400 meters or so. Some are even bigger, I think. But you certainly scale that down. You would not work on a scale of 400 in Blender. As we've seen, when you when you approach 300, you start having problems anyway. So I would scale that model down. Now, I'd either scale it down by a factor of 10 or 100, and that depends on the level of detail that I want. So in this case, I'd scale it down to 4, or maybe keep it up at 40 if I wanted that extra level of detail. It depends on its end application. Our bridge, right. Golden Gate Bridge is nearly 3 kilometers long, for instance, but you wouldn't want to make it 3 kilometers long in Blender. 3,000 Blender units, that's going to be crazy. So you would scale that down. And again, depending on the level of detail you need it, you could make it 3 Blender units if it was something you were viewing from a distance in a game, or just a low poly model of it, I suppose. But if you wanted more detail, you'd probably bump it up to 30 Blender units. So it would be slightly larger than our grid that we start with, but that's absolutely fine. Now, finally, the Earth. Now, that's a big, big object, 12,000 kilometers. And obviously, we're going to be scaling that down. But how far? Again, it depends on level of detail. I certainly wouldn't go any larger than 120, and I'd probably keep it around 12 unless I needed an excess amount of detail. But once you start needing a lot more detail, one of the things to remember is you can always produce another model. So for instance, let's take this Earth as a quick discussion point. So let's talk about scale, level of detail, and models. So one model does not have to contain its all. Use multiple models when necessary. So imagine you're zooming in from outer space, you're approaching the Earth. Well, when you're far away, you can use quite a low poly model of the Earth. It just needs to be a sphere. And then we're zooming in. So it's going to have to get more and more detailed at some point. But we don't need to include all that detail on the one of the Earth that is millions of miles away before we reach it. And we certainly don't need to include all the detail on the Earth by the time we're zooming into the level of, let's say, a city. And then as we go more and more detail, we can focus on the bits that we need. Now, you would have to make multiple models for each level of detail, but that's absolutely fine. Think of the end in mind. And you'd simply transition between these low detailed models to higher detail when you need to. Let's move on to the next lecture. Welcome to importing reference material. In this video, we're going to go through the fact that there are 2 ways of importing reference material. There are basically background images and textured planes. Now, because we know nothing about texturing at the moment, we will be using background images, and they also give us a fundamental control, whereas planes can be a bit more tricky to get right. So let's hop straight over into Blender and experiment with background images. Now, there are 2 ways of doing background images in Blender, and one of them is really simple, and one of them is a few more clicks than simple. So I'll show you the menu option first of all. So if you haven't already got it open, you'll need to open the Properties pane by pressing either the N key. I clicked on the little plus and open up this Properties pane of the 3D editor. Now if we scroll right down towards the bottom, there's a section called Background Images. Now we can click to make a tick in this box and expand this option, and we can add an image. But before we go and do that, I would like to quickly show you the other way of bringing an image in. And if you go to any image on your computer, for example, I've got an image example here, I can click and drag it straight into Blender. I'll just close down Finder there. And we get a similar show as we've got here. We could have just opened up our background image. Now, there's a lot of information in this view here. So the first thing we're going to cover is the fact that I can't see my image. Where is it? Well, there are 2 constraints for a background image. You must be using an orthographic projection. So let's go and set orthographic projection now. So I still can't see my image. You have to be looking along one of the X, Y, or Z axis. So either looking from the front, top, bottom, left, right, etc. So if we switch the view now to bottom, we can see, well, hey, thumbs up. We can see it. If we switch to left, it's there as well. And if we view it from the front, It's there as well. So that means that it's on all of our axes. And we can change that with our first drop down here. So I'm just going to expand the properties pane so we can just see what's going on here. So it's an image, that's fine. It's all views. So we can actually control here where we can see the image and where we can't. I'm going to leave it on all views for the moment because that's fine for the purpose of this exercise. Source image is a single image, that's absolutely fine. That's where we can find the image, which is great. Image example. Going down, so opacity. Now, depending on the darkness or lightness of your image, this basically fades it away into the background, so it's it's not as strong on the screen. And of course, 100% opacity means that you cannot see the model at all. Now, we can see it's at the back at the moment, so let's zoom in a little so I can see what's going on. Now, we have our cube here. Our default cube, and we have the image behind it. So if we have anything on the screen, so if I scale our cube up a little, you can see that our background image is behind that cube. If I move it to the front, it's always going to be in front of whatever geometry you're working on. And this is where you may want to play with the opacity so that you can still see your geometry. Now, in general, you'll probably want it set to front so you can see the reference material itself and so it's not hidden. What does this X thing do? Well, it moves it along the X-axis. What does the Y do? Well, in this case, it does move up or down, and that's a little confusing with the way we're viewing it because that's actually the XZ axis at the moment. But essentially that's going to move it up or down. And those are, of course, Blender units. Then we have our two options here to flip horizontally and flip vertically as well. It doesn't like being flipped vertically, as we can see there. And finally, we've got two down the bottom. So we've got a scale there with the size modifier. And finally, rotation. So we can rotate it around at a set angle. So that's great. We've got our background image there. I think we can now do a challenge. I would like you to import into our Blender file the pinreference.png and set that as the background image. I'd like you to make sure that it's only visible from the front and get the image as upright as possible. I've noticed that the image itself is slightly wonky to one way or the other. I can't remember which way it is. But now, bearing in mind that the real pin is 38 centimeters in height, I would like you to think about the scale that's going to be appropriate to what you're doing in Blender. So pause the video now and import the pin and scale it accordingly. Okay, welcome back. Let's hop over into Blender. Okay, so here we are in Blender. So let's go and import our pin reference. So I'm going to go down to background images and add an image. I'm going to scroll down some more and click open. I've stored mine in my downloads folder. I suggest you store yours in a project folder. And first of all, I'm going to just set it to the front axis. I can't see it at the moment because I'm not looking by the front and I'm still in perspective. So let's change it to orthographic projection and move around to the front. So there is our pin. Now, arguably, I could do the rotation now while it's much larger. In fact, I think I will. Let's just rotate it by a degree. That looks much better to me. Excellent. So let's use a cube or another bit of reference material, it doesn't matter, as a guide, if you will, to scale this reference image. So I'm going to get rid of that one that's there, and I'm going to create a new object. It doesn't matter what it is. I'm going to create a cube. Why not? The radius. So the radius, that cube is actually 2 in height. So we're going to work to a scale of, let's say, 3.8 Blender units. Thinking about, we don't really want it very, very small. We need to work with it. So that's nearly 4. So half of 4 is 2. So we need 1.9 on our radius. That's perfect. That's now the correct height. What we can simply do is go back to here to our scaling, and we can't see which one's scaling at the moment. Here we go. Size, let's just all the way down, and we can't see it anymore. So let's bring our, here we go, let's bring our image to the front. Oh, that looks like it's worked perfectly. So 1.2 seems to be spot on. I'm happy with that. So there we go. We've got our reference material imported, straightened up, and to the right size to work with in Blender. Let's move on to the next lecture. Welcome to choosing the right primitives. So why your choice matters when you're picking a starting primitive. Now, starting with a primitive with the same symmetry and shape as your target model will save you time. So if you're starting off making a book, perhaps you're doing a fairy tale story, then if you started off with a sphere, it would take you a long time to get it down to a book shape. And similarly, if you were making a ball, you wouldn't necessarily start with a cube. So it can be very hard to remove all traces of that original shape. As I say, if you start with a completely different shape, it's going to make your life difficult. Fair enough if you want the challenge, but not a great idea. So here's a challenge for you guys. Which primitive would you use? So we've got some examples on the right-hand side, and they're planes of symmetry. So if you were to cut through that object, it would look the same on either side. Obviously, these are basic examples on there. So pause the video now and fill out which primitive you think would suit the examples on the right. Okay, welcome back. Here we go. So let's explain these as we go through. So a cuboid has 3 planes of symmetry. So imagine a book, a smartphone. In general, you could cut them through 3 ways. You could cut them through the middle, the top, or the front, and they would be the same from a starting point. Remember, this is a starting point, not the end point. Obviously, after you finish modelling, a car will have an actual top and bottom to it and start to lose some symmetry. Now, a cone and a cylinder, well, they're actually the same thing. A cylinder is a special case of a cone. If you imagine a lampshade, it's a kind of a cut-off cone. But if you widen that out, it eventually becomes a cylinder, and then it goes the other way again. So if you were modelling any sort of bottles, a cup perhaps, the Christmas tree type shape, then you would start with a cone or a series of cones in order to make that. Finally, we have a sphere. So if you were making some fruit like an apple or a lemon or a rugby ball or anything spherical, it would be an obvious place to start by using a sphere. Hope you guys got on very well with that. Let's get on to the next lecture.
Hey, welcome back. It's Ben here. Remember, you can always slow the video down because I talk a little bit faster than Mikey. So I'm going to be introducing what are Bezier curves. We'll be telling you why we're using them for our pin, and then you'll be drawing your first Bezier curve. So what are Bezier curves? They are perfect mathematical vector curves. They can be scaled infinitely with no loss of detail. And that means you can create a very simple, smooth and elegant look, but only if you use as few as possible. Let's just click onto this Wikipedia article in your notes to show you a couple of examples of Bezier curves. There's one on the right there. If I scroll past all the maths, you can see some others moving here. They're defined basically by a start point, an end point, and then these blue control handles in this diagram. And between those start points, end points, and control handles, you've got fantastic control over the shape of your curve. So let's go and see how we do this in Blender. Here's where Mikey left you, looking at the front view of your pin with a cube there in the scene at the origin. And what I want to do firstly is just scale that cube. In the X direction, we want the cube 1.2 units like that. So now we have 2 forms of reference. We have a bounding box of the cube sitting there in the scene, and then we have, of course, this background image that we've set up. Fantastic. I'm just going to move this 3D view over the top of the timeline view like that, dragging downwards, just to give myself some more screen space. So without further ado, let's add a Bezier curve so you can see what it does. There's 3 ways of doing that. One is from the Create menu. You can click here, Curve Bezier, or you could do the Shift-A for Add, and that would bring up your Add menu, and you'll find a Curve menu, or you could go to the Add menu down the bottom here, and that's actually the same menu upside down for some reason. Fantastic. So let's add ourselves a Bezier curve. But before you click away anywhere else, remember when you first create things in Blender, you want to be a little bit careful down the bottom left here. And remember, if this pane's not showing, you can make it show with the little plus sign. So if you've pulled that all the way down, like I do all the time, that little plus sign will bring it back up. So before you submit this curve to having been created, make sure you align with view. The reason for that is in our case, we want to make a curve purely in the XZ plane. We don't want it extending in Y at all. Okay, we want a two-dimensional Bezier curve. They can be 3D in Blender. So there you go. You have this squiggly thing here, which you can drag around with the right mouse button. When you do, you'll notice it goes right through, in 3 dimensions, the middle of that reference cube. So we can sort that out by just moving the reference cube backwards. Click on your cube up here in your, on the top right in the outline, and then just push it in Y until it's behind the Bezier curve. Fantastic. Now let's select the Bezier curve again. Here it is. There's your curve. Now I want you to make sure that your Bezier curve when you first create it is at Y equals 0. This is very important. Once it's selected and created at Y equals 0, push Tab or go to Edit mode. Both do the same thing. Now you have control over those things you saw on Wikipedia. You can right-click the endpoint and drag and move it around. Now you see that it's moving in X and Y. It looks like it's moving in X and Y. That is because we have local coordinates selected. You need to be in global coordinates. Blender is very confusing in a 2D view because it actually changes this XY to XZ. This XZ to XY. That's very confusing. So let's be in global coordinates. Now, when you drag around your endpoint, you'll see the Y is not changing, or as good as not changing. The last decimal place moves a little bit. So sue me, that's okay. Let's also click on with the right button on the start point and move it around and see how it works. If you miss the start point, you may grab a control handle like I did. That's fine. So your things that you can control are the start and end point here by dragging with the right mouse button, left button to place, and the same with the handles. You right click and drag to move the handle, and then you left click to place. The final thing you're going to need to know about this curve is how to add new vertex control points. How do you do that? Well, you click on the last one, like here, the end one, and then you hold down Control and left click the mouse button. So you hold down Control and left click with the final endpoint selected. That will create another point afterwards. And again, you can go in and grab and drag these handles. Again, keep an eye up at the transform that this is all in the Y equals 0. So what we're going to do is we're going to outline the right-hand side of the pin. I'm going to start it for you, and then I'm going to challenge you to finish it. Let's put the first control point up the top here. Place it roughly, that's fine. Roughly drag the control points around to where we want them, something like that. And now let's go place that first point precisely. I want it at X equals 0, right in the middle of the pin. I want it at Y equals 0 in the plane of the screen, and at Z equals 1.9, precisely at the top of the pin. Now, here comes the art of drawing Bezier curves. Where do you place the next node? Where are we going to move this guy to? There's lots of places you could put it, but I'm going to choose to put it right here, where the neck of the pin becomes vertical. And let me explain the rule of thumb that I've got for why I'm putting that point here. We want as few points as possible in a Bezier curve to keep it as simple as possible. Every point we add to the curve introduces complexity and takes away from the mathematical purity and elegance of that curve. So you want to use as few as possible. Now, if you were driving a car around this pin, around the outside of this pin, let's start on the left-hand neck here. Here we are steering right, steering right, steering right, and at the top our steering wheel goes vertical. Imagine you've got a piece of white tape on a rally car steering wheel. This is an indication you need to put a new control vertex in. Now we're steering right, steering right, steering right, and at this point our steering wheel's gone vertical again. Another control point. All right, now as I scroll down, I am now steering left, steering left, steering left from the car's point of view. And at this point, I inflect and I go through and I start steering right. So you might want to put yourself another control point here. And then get the handles where you want them, okay? Or you might decide I don't need one there. I can go all the way down to here because this is the first time that the curve changes direction. Because actually here, all of the time, we're steering right, steering right, steering right, steering right, you see? So this is a really subtle point. It's very tempting to put a control point here so that we can precisely define the width of the curve. But the disadvantage of doing that is it's actually one more than we need. We only actually need a control point here, because this is the next time the steering wheel goes vertical. And by dragging these handles, you can get round that curve. Okay, so I've nearly done that for you now. Now, if you accidentally do what I've just done and go into 3D view, not a problem. Check that your curve is flat in 3D and then just come back to a front view. So I've shown you most of it, but I want you to finish this off and get it to spec, to specification. So let's show you the spec slide. Finish the pin outline. Only one half of the pin is needed. The top control vertex even should be at precisely 0, 0, 1.9. The bottom one should be at 0, so it's in the middle of the pin. 0 in Y, so it's in the plane of the screen, and minus 1.9, so it's precisely at the bottom of the pin. I want you to add just one more control vertex, actually, for a total of 4, and then make sure that all the vertices have a Y equals 0, and see if you can get a good outline from that. So pause the video, see if you can outline the pin in 4 vertices total. Okay, welcome back. So adding in these final vertices, we firstly need to select carefully our endpoint. So make sure you're selected on the Bezier curve. Then you come in here and right-click on the actual final control point. And then these handles are really long, so I'm actually going to pull this handle in a bit before I even add another point. Then we hold down Control and left-click at the bottom. And there's my final point. Now, it all looks a bit funny in there right now, but that's okay. Let's sort it out. Let's grab the handles and take control of this curve. So there's one, click, and then here's the other handle, click. Now, you need to mess around a little bit because Bezier curves are very holistic. When you make a change to one part of the curve, it changes the rest. But here are the things that are important. Number one, this bottom control point needs to be at precisely 0, 0, minus 1.9 for when Mikey spins it around in 3D with you. This may be a good time to check your top control point is at precisely 0, 0, plus 1.9. Fantastic. Next thing I want you to check is that the top of the pin is going to be actually flat. And the way to check that is that this right-hand handle here also needs to have a Z value. Whatever you choose for X is up to you. That's by eye. But it must have a Z value of precisely 1.9. Okay, so then it's completely flat at the top. Coming down the curve, it looks okay for now. We'll modify it in a minute. And we have a change of direction here. So we need to grab this control point and make this curve how we want it. It doesn't have to perfectly match this reference pin, by the way. And then this handle here will adjust the curvature at the bottom. Remember, the pin needs to be able to stand up, so you actually want quite a flat bottom. So I'm going to make this handle quite long, watching the entire curve as I do it. And the same treatment at the bottom. This bottom control vertex must be at 0, 0, minus 1.9, but importantly, its right-hand handle must also be at minus 1.9 in the Z. Then you have a completely flat curve at the bottom. So I'm leaving my pin different to the reference pin because I want to square a bottom on it. Okay, because I want it to be able to stand up a little bit better. So the final thing I'm going to adjust here is the handles on this one at the neck. And look at that. That's pretty cool. When you're satisfied with your pin, then you can come out of edit mode back into object mode. And I'm actually going to turn off the background image now because it's kind of distracting me. There you go. That's my pin outline. And I think it looks pretty good. So what we're going to do next with Michael is rotate that around 360 degrees and create you a full three-dimensional pin from this pretty curve. So congratulations, and I'll see you soon.
Welcome to Spin in Blender or Rotational Extrusion. So in this video, we're going to convert the curve that we've made into a mesh object. We're going to learn that a curve is still infinitely editable, and then using the spin tool, we will make our pin. So let's hop over into Blender. Welcome back into Blender. So we have our curve all there and sorted. Now I'm quite happy to get rid of our cube that we made earlier as our reference cube, as we're not going to need it anymore in this case. So I'm going to select that and just get rid of it completely. Okay, we've got our Bezier curve here, which is great, and I'm going to go over to the outliner over here and just name our Bezier curve something more descriptive like pin outline. It's very important that you keep this naming throughout your production, because when your models get more complicated, you're not going to be able to find anything. Right, so we need to convert this into a mesh object, and you can do that by going down to Object, and in my case, I'm going to have to scroll up a little. There we go.
convert to, and we can see the shortcut key there is Alt and C. And we want to make a mesh from a curve. So we're going to select that, and we can see over in the outliner that it's created a mesh object. That icon there has changed. Now, in case you wanted to keep the original data, the curve, you can opt down here in the operator panel to keep the original. And then we can see we get pin outline and pin outline 0001, and one is a mesh object. Now I'm going to go straight into that because I know this mesh object is about to just become our pin. So there we go. We've converted that curve straight into a mesh. Now we've left the curve there. The curve is infinitely editable. It's a mathematical calculation, which is great. Once we've created a mesh out of it, it essentially becomes solidified, as we mentioned. And if I hide the pin outline by clicking on the little eye icon there, we can see that our pin itself is now made up of, if we hop into, select it first, hop into edit mode, it's made up of a series of vertices. If we highlight the entire lot, because we're going to need that in a moment, we can then perform some operations on it. So for instance, if that was just something we wanted to extrude out, we could do that straight away, which is great. But we want to rotationally extrude. How do we do that? Well, once we're in edit mode and we've selected all of the geometry we want to manipulate, in this case it's everything, we can go to Tools on the tool shelf, scroll down a little if you can't see it already, and click straight on Spin. And we can see the shortcut there is Alt and R. So by pressing Alt and R, we perform a spin. Now, that doesn't look anything like our pin. So why? Well, we're going to have to look down in the operator panel. So I'm just going to make this a bit bigger because there are a few more options here. And let's go down them one by one. Steps is the number of steps there are. It increases. The more steps you have, the more detailed it becomes. Now that's quite a cool shape, but it's not a pin. Angle, well, that is the angle at which it goes around. In fact, that looks like some sort of funky wheel or a brake disc or plate at the moment, which is great. And obviously, you rotate all the way around until you meet 360. That's fine. The center, well, the center moves each individual part of the rotation, and we actually just want everything here at 0. So if it's not at 0, do set it at 0 now. Right, now everything's at 0. It's still not quite right. We need to play with these axes down here, and we're not rotating it in any way on the X and Y, so we can definitely delete that, and we have a pin shaped. Excellent. It's only 42 degrees of a pin, but nonetheless, that's always good. Right. 160 degrees, sorry, I was reading the wrong thing there. Steps, 42. Angle, 160, that's great. Okay, it's challenge time. I'd like you guys to finish the pin. So go ahead and finish off the pin and consider the following, please. I'd like you to remove any doubles that are created during the process. Get the normals the right way round, because there's a chance that they will be the wrong way round. And so there's a little hint there for you. And finally, set the base of the pin on the XY plane just to finish it off. And that's where Z equals 0. So go ahead, pause the video now and give that a go. Okay, welcome back. Let's hop back over into Blender. So over in Blender, well, straight away, I know I want 360 degrees. So I'm just going to whack that in straight away. And I'm just going to have a look at my pin and just adjust this Z value to, you see, that's normals are the wrong way round and that's normals are the right way around. So it's quite a distinctive color change and your eye will tune into that very quickly. So now we've got that the right way around. I do want to change our steps. I think that's a few too many steps, actually. I think that's over the top. So I'm just going to lower that down. No, 16 is a bit too low. 32, a bit high. I'm going to go for, in the middle of that, 24. Yeah, there we go. I'm happy with that. Now, one thing to bear in mind is because we've gone around a whole 360 degrees, there will be a series of duplicate vertices actually along this seam that we can see where we started from. because it also put a layer down when we finished. So we need to just select our entire model, make sure there's no further doubles, and on the tool shelf I'm just going to remove doubles as we've done before. And we can see I've actually removed 120 vertices at that point. So there was a bit of mess in our model there, but now it's all gone. Excellent. So the one thing left to do then in our model is just lift it up so it's actually on the XY plane. So I'm simply going to grab it, I'm going to lock it to the Z axis so it's still in the middle, and if I believe it's 1.9, and that should make us all the way up there. I'm just going to change the view to the front. And there we go. Yep, I'm happy. That looks like it's bang on the bottom. It is. And there we go. There's our pin. Remember to share this in the discussion so I can see what you guys have been up to, and I shall see you in the next lecture.
Welcome back, Ben with you again. We're going to be talking about assigning materials to faces. We want to put some stripes around the neck of our pin. So in this video we will introduce the Material Properties panel, tell you how to create and name materials. We'll be talking briefly about users of materials and how that impacts trying to delete them. And we'll also, of course, show you how to assign a material to a face. So the bit I want to bring your attention to is on the right-hand side of Blender, over here, in this panel here. Now, what is the panel? It's called Properties, you can see from the icon. So in the Properties panel, I want you to make it a little bit larger, and you can actually scroll left and right. There's a lot of little controls in the Properties panel. I'll show you. I can either hold down the middle mouse button, or I could scroll up and down. Or for the sake of clarity, I'm just going to make the panel bigger for you guys, okay? So click on Materials there. And what I want you to do to start with, so that this view looks like the slide, is I want you to go to where I'm hovering, at the top right-ish, where it says Add a new material slot, because the Materials panel starts very, very sparse. There's no slots, there's nothing to be had. So you click plus, and now you're going to get a little bit more information. And then I want you to click New. So we've made a slot. It's just an empty slot for a material on the pin. Now click New. And now you're going to get to this view, which can look a little bit overwhelming, especially if you scroll down. A lot of stuff there. I just want to focus above this line here for now. So I've got a slide for you which will help you to focus your eye in on what's going on at the very top of this materials panel. So we've already done the thing at the top, which is we've selected the material tab. Next thing you see is a breadcrumb. It basically tells you where we are, what are we dealing with. We're looking at the scene, that's that first little icon. Then the cube is the object that we're dealing with, and then we're looking at the materials of the cube. So it just reminds you where you are and what you're working on. The next list is a list of applied materials, or it's at least a list of material slots for this particular object. So now the pin has one material slot. And we did that on the right-hand side with the Add, Remove, Copy, Paste buttons. And then you've got another little slither along the bottom, which we're going to be using a lot, which is where you actually manage the material. So let's dive back into Blender and take a look at how this works. So here we made a material slot, and you can make your material slot panel bigger if you like, by dragging like this. And we created a new one, and it called it material. Well, let's call it pin. So click into here, where I'm highlighting, and just type pin and return. And now you'll see that we have a material called pin. Okay, now there's another type of material we're going to want on the pin, of course, which is going to be for the stripes around the neck. So let's go ahead and make a second slot. Now you get a simplified interface. You need to make a second material. There it is. Again, it calls it material, and we're going to call it stripe. So now we have two materials, pin and stripe. Okay, and if you click here to the left of the word pin or stripe, you'll see Browse Materials. You can also see those two materials. This is like a library of materials that you could pick up, and you can actually apply these to other objects in the scene if you want later. There's some other more advanced controls over here we're not going to worry about for now. What we do need to do is give our stripe a different color. So if you scroll down a little bit, you'll see under Diffuse, which is the color that it scatters off in all directions, it's currently white. Let's make it whatever you like, but say red. Okay, so we have two different materials. They're both simple diffuse materials. You can see the preview here. One is just a kind of very boring grey colour, and the other is a slightly more interesting red colour. Okay, fantastic. So what I want you to do then is to go into edit mode, because now that we've set up our materials for our pin, we cannot apply them to individual faces until we are inside edit mode. So let's go into edit mode. All right, and then what I want you to do once you're in edit mode is I'm going to challenge you to actually create the two stripes around the neck of the pin. I'm going to choose a couple of face loops, this one here and maybe one a little bit further up. But I'm going to leave it to you to actually do this for yourself. I just want to bring your attention to one more thing, which is now that you've entered edit mode, 3 new buttons have come up here in the panel on the right hand side under the material slots. You have Assign, Select and Deselect. The Select button selects all the faces that have the material that you have selected in the list above on them. So have a go with that. And the Deselect button does the opposite. It deselects all the faces that have the material you have selected above on them. So it can be pretty powerful. So Assign assigns the currently selected material in the slots above to the geometry that you have selected in the scene view. The Select button selects the entire thing, so the pin, and Deselect would just deselect the entire object, i.e. the pin. So if you wanted, for example, to apply the pin material to the whole object, then you would click Select, which would select the whole pin, click on the word pin, and then click Assign. You'll actually find that's already happened by default. When you create your first material, it gets assigned to the entire object. So when you're going to make this stripe, you're going to need to select the face loop geometry by doing that in the 3D view. Then you're going to need to select the stripe and then click the Assign button. So those 3 buttons only come up in edit mode. So select a face loop for one stripe. Hint, you can select a face loop by holding down the Alt key in edit mode and then using face select. So you've seen that in a previous video with Mikey. Assign the stripe material to that face loop and then repeat again for another face loop to create your second stripe. So basically make 2 stripes on your pin. Go ahead, pause the video and try that now. Cool, welcome back. So let's take a look. A few things to check before we go. Firstly, you do need to be in edit mode here because we are dealing at a face level, not just an object level. Second thing is I want to make sure you are in Blender Render here. You'll get some very different menus if you're not. Okay, fantastic. So we need to select a face loop. So we go into face select mode down the bottom of our screen. And then we hold down Alt. And then we click on one of the faces. And there you go. We get a face loop selected. Now, with the correct material selected over here, you click Assign. Boom. There we go. Now to do it for the other one, it's the same job. You hold down, you right click, face loop is selected, click Assign. Perfect. Look at that. We have stripes on our pin. Now you can preview this in various ways. You can come out into object mode if you wish. And then this is where you can use the various different rendering modes for the viewport. You could say wireframe. Now in wireframe, of course, you're not going to see any of the materials. That's the whole point of wireframe. You could go to solid colored. Now this is just a very fast preview mode for use inside the viewport here for when you have complex models, and you do see your colors there, which is cool. You could go to texture, which is similar, but it's actually using the scene lighting now. It's using this lamp, which is why you only see it lit from one side. Or you could go to rendered. Let's just leave it with that, and that would show you what the final Blender render output may look like. But for now, we are just considering solid, which we have been all along. We are staying with default lighting, and we're just trying to get different faces, different colors. And we've done it. We've got a whole ring of faces in red, which is pretty cool. So congratulations with that. Do feel free to customize these things if you want. You can always click back onto the pin. You can go back, say, into the pin's material and play with its diffuse color here and have a vile different color for the pin if you wish. You can also do the same for the stripe. And if you want to get a little bit more adventurous, we're going to explain all this later in the course, but if you want to play with things like specularity and some of these other things, not going to do any harm, you're welcome to go and explore. But for now, the important thing is that you know how to put like a white color or whatever color you like on the back of the pin, and then a different color on those those face loops around there. So well done, you've got a colored pin, and we'll see you soon. Hey, welcome back. So we're going to talk about exporting models with materials now. We think we've nearly got our pin finished, and in this use case it's going into a game engine. So let's carry on the process. Remember, let's get it finished. Let's talk about how a blend file may appear elsewhere, in this case in Unity. How to export as a FBX file with materials attached. Why using a blend file is leaner if your target program will support it. Briefly talk about smooth shading and normals. You may have noticed the pin is a little bit kind of blocky. And then I'll explain why we may want multiple levels of detail. So let's just have a look. What's this about workflow and leanness? Well, the leanest thing we can possibly hope for is that our target package live reads.blend file. So Unity, for example, if you put the .blend file in the Unity assets, it will read it live, and you change the Blender file and it changes immediately in Unity. You may have a 3D printing software that does the same. You may have a different game engine, whatever. So that's the ideal. The next best thing, if you can't do that, is to save as a blend file but just import into your target package. So at least you've only got one thing to do every time. You make a change to your model, and then you go to your target package and you do another import. And the trickiest thing that you may need to do is to export from Blender every time you make a change as an FBX, an STL, or whatever, and then import into your program. So you've got lean, medium, and hard. It's a bit like burgers. Okay, so let's take a look at all this in practice. Here's our nice stripy pinny thingy widget. So what I'm going to do is I'm going to crack open Unity for you, which is a very popular game engine. Now it's free. If you want to go and download it from Unity's website, you're very welcome to, and you can play with it. But this is a Blender course, so the purpose of me putting Unity up here is I want to show you the livest and leanest possible way of dealing with a blend file in another program. So if we don't export, rather, but save a copy of the bowling pin right into the Unity or your target program's appropriate folder. Now, in the case of Unity, that is the assets folder. So I've put it in my target programs folder. Now Unity's very well behaved with this. What it does is it notices something appeared in its asset folder, and I can just put it straight into Unity. Here it is. There is your bowling pin in a game engine. Isn't that pretty cool? I'm going to move this light out of the way because it's very distracting. And there you go. Congratulations. You have something in a different program. Now the cool thing about working with a program that works in my leanest paradigm, remember the top one here, the target package live reads the blend file, is this. Look, if I go into Blender and I say go into edit mode and I go grab maybe one of these faces and kind of yank it out like that, if I save the blend file, watch Unity. See, it's immediately changed in Unity. There it is. You see the pin has the thing in it, which is, I think, is very cool. Now I can undo that and resave, and Unity will immediately notice the difference. So that's the best possible workflow. The next best workflow is that you need to kind of import into your target package, but it's still a blend file. And the trickiest workflow is where you need to go export as, say, an FBX. Let's try that from Blender. Go ahead and try exporting your pin as an FBX, by the way. And you could say stick it in your downloads and call it bowling pin. You can leave all the settings default. And then you have an FBX file. Then you have to go over to your target package and let's delete everything that's here for now. And then you go in your target package and you import a new asset and you go find it and then you import it. And eventually you end up in a very similar place. Now notice when you import an FBX, it also has a materials folder. The pin and the stripe are preserved. And if I open up this thing, it has the camera, the lamp, the pin mesh, etc. And I can still pop this pin in my scene and it still behaves. So either way is good, but of course now if I make a change in Blender, I want that pin to look more like this. Saving it's no good. I have to export it as an FBX again and then re-import it. You see how much more of a hassle that is than just actually saving the blend file. Yeah, much more of a hassle. So I am going to work with the blend file because it's a lot easier for me over here in Unity. So I save my blend file, look at Unity, and it updates immediately. Lovely. Okay, fantastic. So let's go back to the slides and talk about the other things. So you've seen how a blend file may appear elsewhere. You've seen how to export as an FBX with materials. It all just kind of happens. And you've seen that using a blend file is a much leaner way of doing things. Now I want to talk about smoothing and normals and then multiple levels of detail. So here is our bowling pin in Blender. And if we're in edit mode, remember that you can go down here in the properties panel and you can go somewhere. You can say show me the normals, and they're vertex normals in Unity. So I'll show the vertex normals. There they are, the little hairs. And they are one per face. Another way to show it is sticking out of the faces instead of the vertices. Same number of normals roughly. So the problem with this pin is both in Blender and over in Unity, it's pretty rough. You can see every single cell. Now you may say, I should turn the poly count up, but hang on, hold your horses. It's already got a lot of polys. It's already got, 1,680 triangles, which is plenty. What we need is something called smooth shading. And back in object mode, in Blender here, you can go down under Tools and you can click on Shading Smooth. And look at that. It's really looking pretty smooth now. And if you do that and you resave it, resave the bowling pin, the great thing is that those extra normals, which you'll learn later help determine how the thing draw, they come into Unity as well. Same number of polygons. It's amazing. If you don't believe me, then look here in Unity. It tells you 1,680. Or look back in Blender, 1680. But it's a trick of lighting that's making this look smooth. In fact, I would even go as far as to say that Unity is doing a better job of shading that than Blender. Maybe when we go to the rendered mode, Blender, there you go, Blender's doing a pretty good job in rendered mode. But Blender's preview, its solid preview, is not quite as good as Unity's rendering. But anyway, there you go. So we don't need to up the poly count crazily. What a lower poly model like this will not do for us is hide the fact that the edges are still a bit like max headroom. You can still see the geometry on the edges there, and that of course is exactly the same deal in Blender. It doesn't matter how much smoothing you put on, you're going to see the geometry at the top of the pin, whether it's flat or shaded. You see the edge, the outline, the occlusion of the background is going to be the same. But going from smooth to flat really makes a difference to the visual appearance, especially with a good shader like the one here in Unity, or when you actually render later in Blender. Cool. So the final thing I want to talk about now is how about, I'm in a game engine, I may want this pin to do something, right? We presumably would have a bowling pin because we want to make maybe a bowling game and we want to do something with it. So I'm just going to make a floor really quickly here and just put it below the pin. So I'm just giving the pin some physics now, and if we play the game, the pin falls straight through the floor. That's no good. So what I want to do is add something called a collider. Now the purpose of this is that you as a designer are going to have to help with this, because watch what happens. If I now try and add something called a mesh collider to this, and I say, well, what's the mesh? And I go and say, well, it's the pin. Look what happens in Unity when I try and run this. It's going to complain. Non-convex mesh colliders are not allowed. Now, Mikey's going to talk to you about what a convex mesh is, but it basically means that none of it sticks inwards. The neck of this pin is concave. And this game engine will not allow concave. So Mikey's going to be showing you how to make convex meshes. So say I say to Unity, okay, make it convex. It will go, I can't, because it's got more than 256 vertices. My brain hurts. It's got far too many vertices. Look in Blender, the vertices are 870. So it just doesn't work. It can't work. I can't make this work. I cannot make my pin collide with the floor. I'm now an irritated game designer. So I'm going to go back to Mikey and say, Mikey, I want a lower poly, less than 255 vertex collider. And the end effect of that is going to be something like this. He's going to provide me with a different mesh. I'm then going to bring that mesh in here. And it is going to be a green outline like this, and it'll be kind of something like that, but it'll be more pin-shaped. And when we've finished, what will happen is my pin will actually, if it starts with some rotation, it will actually land and fall over, but properly. You see, that's just dodgy, because whatever I do with just a cylinder, either this part of the pin hits the ground properly, or the neck does, but not both. You see, if I thin it down, it'll go through the floor, etc. So our mission now with Mikey is to make a mesh that is 255 vertices or less, representing the same shape and scale as the pin, but is also convex. It must be a convex mesh. So from this tip of the pin to here, it's going to have to be a straight line, nothing going in. So that's what comes next, and I hope that was helpful. You can see the fate of your models when they arrive in things like Unity. See you soon.
Hi, it's Michael again. Welcome to Creating Collider Meshes. So in this video I will show you how to control the number of vertices, and we can do that in a couple of ways. Firstly, we'll be creating a convex hull so that the collision mesh works properly, and we'll be introducing the decimate modifier. So let's hop straight on over into Blender. So here we are in Blender, and the first thing to realize is that what we're about to do is destructive. So we've got a couple of options how to move forward. We can either create a duplicate of our pin and then work on that mesh, or we can create a whole new file. So in this case, I'm going to create a whole new file just to keep things simple so we don't have multiple models in our scene. And also, so when we look at the info pane at the top here, we can see the number of vertices, and we can just read that out and know that we've met our design requirements. So I'm going to go to File, Save As, and I'm going to save it as Bowling Pin Collider. Imaginative name, as you can imagine. So at the top here, I can confirm that's the case, Bowling Pin Collider. Excellent. So the first thing I'm going to do is make sure this is simple, because when Ben imports it or when we export it to any other package, we need to make sure that we don't put in a load of other gumph as well. So really some of these things in the outliner can go, so we can get rid of the camera. We don't really care about that in this case. The lamp can also go, and the pin outline can go. Secondly, I'm not interested in any materials because this is literally a collision mesh. It's not going to be seen by anything. So in this case, I'm going to delete those two materials, and I'm going to check in this here that they've got a 0 against them. Great. So we know, I've just reassigned it. So I'm going to get rid of that again. That means that on the save and reopen, those materials will go. So now we've got our basic pin down. The first thing we're going to do is actually make the hull, our shape, our model here, convex. And we can do that in two ways. And the first way is hopping over into edit mode, selecting all of the model that we want to adjust, going to mesh, vertices, and then up here we have convex hull. Now, the other way of getting to that point is in the 3D window here. If we press the space bar, it looks like that was the last thing I searched for. But we can type in here an action we want to perform. In this case, convex hull is in there, and we can just press enter. And it makes our model convex immediately. So we've got no more of the pin neck coming in. And we can take a quick look at the number of vertices to see that it has dropped, and it's dropped down to 482. So we're not quite at our 256 limit yet. So the next thing that we can do is start simplifying our geometry. Now we could go in manually and start doing that, but there is a tool called the Decimate modifier that will do that for us. So if we go over to our wrench over here, or spanner, and we can add a modifier. And we have here on the second column, the generate column, decimate. Now if you click that and we start playing with the unsubdivide, it's a nice one to look at because it's easy to see and visualize how it breaks up our geometry. And if we increase the iterations, nothing happens. Why does nothing happen? Well, twofold. Number one, we're not in object mode. So let's hop back over into object mode. And that looks a bit funny. So let's bring the iterations back down to 0 again. So we've got our basic pin shape here once more. Now we do want to change the shading back to flat. And the reason for that is so we can see what's going on. So we can see here with iterations we can increase that and the model will get simpler and simpler. So what I'd like you to do now is a little challenge. I would like you to create our collider mesh. So remember, we've got a hard limit of 256 vertices. Ensure, if you've not done already, that it is a convex model. And finally, the base must be flat. There must be something for it so it stands up. So hop into Blender now, pause the video, and complete this task. Okay guys, welcome back. Let's hop over into Blender and do those tasks. So the first thing is deciding how many unsubdivides we are going to do. So if we increase our iterations, we can see that at one point it becomes totally unusable. At 5 iterations, that's complete garbage. So let's reduce that and see what happens in the rest of them. So here I think this looks like it maintains the original width really well. So at 0, that's fine, we've got the original width. At 1, we've got the original width. At 2, we've still got the original width. But it starts from 3 and above getting thinner. Now that's not going to be any good if we've got a bowling ball hitting our pin. In fact, the bowling ball would end up going inside the pin and hitting the collider beneath the surface. So looking at this, I think 2 iterations would be good. And let's see the number of vertices that lowers to. That lowers well inside our limit to 122. And finally, I'm going to click apply on this modifier. So it changes our mesh. And so this is now the mesh we're working with. Excellent. So the next stage is actually making this bottom flat. So there's a couple of ways of doing that. And I'm going to go in. I'm simply going to view it from the bottom. So view bottom. And I'm going to hop into edit mode so I can do some work. And let's zoom in. So we have the bottom of our pin here, and it's really just this area here that we need to be flat, and we can double check that. So I'm going to go into edge mode and select this edge loop inside here. So remember, that's Alt and right click to select an edge loop. And then I'm going to flip back over into front view and make sure that is the right edge to select. Oh, let's go back into front view and go down. So here we have, we can see there that it's certainly not flat, and I think I can still do it. I deselected there, edge loop there going round. Excellent. So the final thing we can do there is, if we open up our properties panel of the 3D editor, we can set the Z coordinate to that entire edge loop to 0. So we're going to go in there, making sure it's globally 0. And there we go, that's totally flat. So that's going to make sure that's not going to rock or fall over for Ben. So let's save this file now. I'm going to send it over to Ben and make sure that it works as he expects it to.
Thank you, Mikey. So I've imported your much more compact mesh here and added it to my pin. There you can see the convex lower poly mesh there, and given it a bouncy material, let's see what happens. Boing. Ahaha. Much better. Awesome. Now that's a game dev and an artist working well together. See you soon.
So we've created our pin and we're moving on to the bowling ball. So welcome to choosing the right sphere. So in this video, we're going to learn that the sphere is just the defining shape. The mesh topology of that sphere can vary greatly. And just for example here, we can have a UV sphere, an icosphere, and even a cube. And we'll be taking a brief look at the subdivision modifier. So let's hop over into Blender now and experience some of these firsthand. Okay, so welcome back into Blender. I have loaded up a default file. If you've still got a previous project open, do remember to save it before closing it and moving on to this. Let's start not with the cube, we'll go on to that in a moment, and we will add a mesh object in object mode that is a UV sphere. Let's take a look at that. And before we do anything else, let's boil it down to its fundamentals. How is it made up? So let's have a look over here in the operator panel. So we can see it has 32 segments. Let's play with that. Let's move it up and down. Excellent. So we can see that's changing the vertical ones, a bit like a segment of an orange. So that's a good way of remembering that. And the rings, yeah, there we go. The rings define how many are going around the surface around here in circles. So we've got our rings there and our segments coming vertically, and the rings are horizontal lines going round. Latitude and longitude, I suppose, much like the Earth. So if we boil this down to its very basics, so it can only have a minimum of 3 segments and 3 rings, we can see that's what it looks like at its simplest form. So some sort of diamond or something along those lines. And as we increase the segments, it can get very, very smooth and detailed. But you end up with a stonking great bit of geometry there. That's 64,000 faces, 130,000 triangles. So that's a pretty high def sphere. Usually you would not be modeling anywhere near that. So we'll just set that back to where it was before at 32 and 16. And we can adjust the radius here to whatever size we want. As always, I'm going to leave that at 1. So I'm going to leave that on our view. I'm going to open up the outliner here. And I'm just going to hide that sphere from view. So we can open it up again in a moment. So that's that object created. Let's now play with another type of sphere, an icosphere. So an icosphere, let's go down to the basic. So we've got subdivisions here in the operator panel. Let's turn that right down as low as it will go. Okay, so let's inspect it. Let's move around. And we can see quite clearly that this is a spherical-like object that is made up of triangles. And the more triangles there are, the more detailed and more spherical it becomes. But it's always triangle, so the entire surface is completely even and divided with these triangles. However,
that can cause problems with your geometry later on because there's no defining edge loops on that, whereas with the UV sphere there is. So let's close off icosphere. So we've experienced those two. I'm just going to up that back to about 3 or 4. Yeah, that's quite high def there. We'll leave that there. So let's hide that one. And then I mentioned a cube. And most of you will probably thinking, what's this guy on? Is he off his rocker? That is not spherical. Not yet. So much like an icosphere is made up of a series of triangles, if we subdivide this cube, then we actually end up with something that's rather spherical. And this is a modifier that we'll use quite a bit later on, but I just want to hint on it now because it's a very powerful modifier, but it does come with some constraints. So if we hit the modifier tab up here in the properties pane and add a modifier of type, here we go, subdivision surface. So it's in our, gone off there, in the generate, but if we scroll down, we got subdivision surface. And you can already see with it set here in the no operator panel this time, over here in the modifier panel, there is a number of subdivisions. So 0 is no subdivisions. But if we subdivide once, we get a kind of spherical shape. And if we bring up our icosphere, we can see it's still slightly bigger than what it was before. But however, when you subdivide a second time, and we hide our icosphere again, we can see it's gotten smaller. And if we subdivide again, it gets closer and closer to a sphere. Now, it's a little bit wonky still, but we're almost there. And there is an operator called toSphere, but I'm not going to show you that at the moment. Just want to show you that the cube can actually be a sphere using the subdivision surface. And I'll just click apply to apply the modifier to our cube. Now there is one thing to take into account whenever you subdivide an object like this, and if I hop into wireframe mode you'll see it really clearly. So in wireframe mode, if we enable another one of these objects, you can see that those two pretty much line up with one another, but this sphere in the middle is nowhere near. In fact, I think it's about 16% too small. So if we go into view and set it to orthographic so we can make a judgment on size, a proper one, and then just move around it because it's a sphere, it doesn't actually matter which way you're viewing it from. If we decide to scale our cube, ironically, because it looks nothing like that, we can see down in the lower left the scale by which it needs to go up by is about 0.16, 0.17 in order to match the same actual size of the sphere we're working on. So there we go. There's 3 different types of sphere to rack your brain round. Now, one final thing on this cube, because I've just spotted it by looking at this wireframe actually. So let's hop back over into solid mode and hop into edit. Now you'll see here in particular and in 4 places along the top and bottom are the remnants of it being a cube. So you can never really get away from the fact that that was a cube. You can see it straight away here that it in fact was a cube because you've got these points joining together, but it's still spherical in shape. Now the great thing about doing this is you end up with a mesh topology that's all quads rather than all triangles, which has its benefits later on. So, I feel a challenge coming on. I would like you to choose a sphere type and make a ball. So choose your sphere type, and the way that should be guiding you is you should be thinking about the placement of finger holes. Which one of those 3 that we've just been through will enable us to equally space finger holes without causing us any problem? So try out all 3 spheres, think of about equal spacing for our finger holes. Now, according to the Wikipedia, bowling ball's diameter is somewhere between 21.59 and 21.83 centimetres. Wonderful. So do pick an appropriate scale to work in, as we've done before with our pin. Finally, make that sphere and we'll cover the finger holes next. So don't worry about making those at the moment. We'll do that in the next lecture. Pause the video now and give that a go. Okay guys, welcome back. Let's hop over into Blender. So let's think carefully about our sphere that we're working on. Well, we want equal spacing. Now we can see by looking at this sphere, which is made from our subdivisioned cube, we can see that that is not even. It does vary. Our mesh topology varies and it gets closer and closer in funny shapes. It's not all complete squares as it goes around. It can't possibly be that. And it ends up at funny points here. So that would be no good for making our pin. So I'm going to hide that by clicking the eye over here. I can't do that because I'm not in object mode. So let's get rid of that. Let's have a look at our UV sphere. Now, this is great for globes or perhaps an eye by the looks of things because things meet at a pole at the top and bottom. However, again, this isn't evenly spaced. If we look at some of the squares running around the middle, they're squares, and as we come up to the top, they're no longer there. So that would be a real pain to work with if we wanted even space stuff. So that leaves our final one, which is the icosphere. And looking at this, anywhere we want, we've got lovely segments and it's even across its entire surface. So we will work with our icosphere. Now I'm going to work to 2.6 Blender units, and that will actually align it to the same scale that our bowling pins are at as well. So it's a 10 times scale. So let's do that now. So I'm going to scale it up evenly on all axes by... Because it started at 1, I can just do 2.1, oh no, 2.6. That's right. And there we go. We have our bowling pin at times 10 of real size at 2.6. So again, it fits on our plane nice and neatly. And there we go. We've created our sphere at an appropriate scale, ready for our finger holes, which we will make in the next lecture. See you soon. Welcome to subdividing an edge and to sphere. So in this video we will be using the subdivision tool to add edge geometry, so adding some more vertices on an edge to take more control out of it, and then using to sphere to create a circular hole. So let's hop straight into Blender and carry these out. So here we are in Blender with our Tsumbi bowling ball. So first of all, a bowling ball is nice and smooth. So I'm going to find on our tool shelf here under the tools tab, smooth shading. So we've got a nice smooth surface. And I'm going to hop over into edit mode. Now, we've got a series of triangles we can work at here, and the subdivision that on the modifier that we chose, has generated a few artifacts. If you look closely, there are a series of 6 triangles, so hexagons being created, but also occasionally there's a pentagon where they join up, and around that pentagon, the geometry is just a bit distorted around there. So we're going to stay clear of the ones with 5 going around them. We're going to stick to the 6 ones. So I'm going to find a space in the middle and we're going to create one of our holes. So here is absolutely fine. So I'll go to face select and click on these faces here. I'm just going to select a group of them. You could use a series of selection methods to do that. I'm just holding down Shift. And what we can do here is literally extrude in. So we'll see what that looks like if we do that. So we've got that there. That's being extruded in. That's great. Let's see what that looks like by hopping straight back over into edit mode. So it looks like there's a hole in the ball, which is great. It looks quite a deep hole. I haven't gone through the other side, fortunately. No control over that. And it looks very rough. I mean, that looks absolutely horrible. It doesn't look like an appropriate size hole to begin with, and neither does it look the right shape. It's a hexagonal hole. So even though we've got smooth shading turned on, that's not hidden the fact that we've cut a hexagon into the surface of our model. So let's hop back on over into edit mode, and I'm going to undo that last step of geometry. Okay, so we need to have more of a step going in, and one of the easiest ways to do this is to first of all we're going to select an edge loop. So we want to select the edge loop that's going around our model here, the hexagon basically. And if we go to edge mode, hold down Alt and try and do that, it won't work. And the reason it won't do that is because there isn't an edge loop that's well defined there. It doesn't know which way to go. I mean, these are all triangles, so it doesn't know which way to go. Each time, it doesn't know whether to go this way, this way, or any other way. In fact, it's got 1, 2, 3, 4, 5 possibilities in direction. So Blender just does not know which way to go. However, we can help it by simply selecting some triangles again and insetting. So I'm going to use the shortcut key I, and it doesn't have to be by much, it can just be by that. Now, the moment we've done that, we've actually broken up and we've created a series of quads around the outside of our new hexagon. Now, when we do that and we select an edge loop, when we hold down Alt and select that, we actually get the edge loop itself, which is brilliant. That's exactly what we wanted. Now, the tool to sphere can be gotten at in two ways. You can hold down Shift, Alt, and S, and we see in the lower left the command to sphere has appeared, and that is one of these proportional things. So it goes from 0 to 1, and as we can see, that's going backwards and forwards. It's making absolutely no difference to our hexagon. And the reason for that is because there's only 6 edges, that is already spherized as much as it can. So we need to add more edges, even though the shape will be the same, but we need to add more edges so that it can spherize or make it circular in this case, since we're dealing with almost a 2D object. So I'm going to cancel that by hitting escape. The other way you can get to sphere is to hit the space bar, and you can see that was my last search. So this is a very good lookup for commands if you can't find them. And we can see if I type in sphere, it gives us a couple of choices there, and to sphere, and it also gives the shortcut keys Shift, Alt, and S. So brilliant. But we know that's not working at the moment, so we have to subdivide this edge. So we leave that selected, and we can do two options. We can either go to subdivide here on the tool shelf, or we can go to mesh, edges, and subdivide, or you can get to another menu which is on the W key as well. And if we go W, and subdivide is right at the very top, very powerful. And take note of what else is on here. It's a specials menu. So we just want subdivide, and that's cut every one of these edges into 2 because we've subdivided by 1. So it's cut everything into 2. If we subdivide by 2, it's cut everything into 3 and 4, etc. etc. So now we've got, I'm going to go for 3 and see what happens now. And we can go straight on and try and to sphere. So Shift, Alt, and S. And as we move the mouse to the left and right, we can see at 0 it remains a hexagon in shape. But now as we approach 1, if you look in the lower left there, as it goes up towards 1, we get a lovely circle in our mesh. Brilliant, that's exactly what we want. So let's hop straight into face mode again and select these 6 slices of that pie and try pushing that into the model, and let's see what happens. Let's go into object mode to remove all that. So we're almost there, but it still looks horrible. It looks now like it's a circle cut, but we're seeing the extra geometry, the hexagonal geometry around it, or the series of triangles that make that up. So we need to do one more step to make that nice and neat. So if we hop back into edit mode and undo that step, we can do one final thing, and that is insetting this by a little bit before we then extrude inwards.
Now, once we've done that and we hop back over, we see that that nasty geometry surrounding the hole has gone. So by insetting, we have given it the opportunity to not look so horrible. Okay, I think it's challenge time. Okay, so I'd like you to create the next 2 circles we need. So if you have done, undo the extrude into the sphere. We're going to deal with that in a moment, so it's correct. Then we're going to create 2 more holes. And then using reference materials, just so you get the hole positions right, so use reference materials to guide their placement. Pause the video now and give that a go. Okay guys, welcome back. Let's hop over into Blender. Right, so we have our 1 hole here, and I'm simply going to go a bit further up, and I'm going to put 2 more holes. Let's see, they have to converge relatively close to one another. So, design decisions. So, I'm going to pop it in perspective mode, I think, just so I can get an eye on the ball. Yeah, that's going to be about right there. So we can see the line coming up here. So no, it won't be there. Not at all. It's probably going to be there and there. Now that looks a bit too, that's far too close together. If you look at reference materials of pins, that just won't look right. So let's remove that and that one. Well, I'll keep that as a reference. Because I will need, that will be the lower triangle of the next set that I can possibly use. So that one there and that one there, and let's follow the line down. No, I've got that wrong. I'm blind as a bat when it comes to this, obviously. Let's zoom in a little further and see if we can actually get things lined up. So there will be a flat edge coming up here. So the next available one is that one there and this one here. Now you can see what I'm getting at there. I'm just trying to make sure that it's lined up appropriately. And actually that one looks a bit too far apart. So is there anything in the middle of this one here and that one there? Nope. So I'm going to leave it like that for the moment. Now, because I've selected them both at once, so you can do this, by the way, so we can inset at the same time. Now, I cannot remember how far I inset before, so I'm just going to do it by eye. That looks about right. And now we need to select those 2 edge loops. Let's try and do everything in one fell swoop here. So that one and that one, great. I'm now going to subdivide those. So go to subdivide, and we set them to 3, which is great. We can do that. Now, with them both selected, I'm not sure at this point if it's going to sphere correctly. No, it's not. You see there, it's doing something weird. So we are going to have to select these individually. So let's select this edge loop here and then go to sphere and whack that up to 1. So it's 100% spherized. And now just select this one and do the same. So Shift Alt S, or you can go spacebar to sphere. And there we go. We've got our next circle. And of course, my instruction before was to undo your extrude here. So if you haven't done that, what can you do? In fact, what we will do in the next lecture is correct that, as if you had made this mistake. That's absolutely fine. And I shall see you very shortly. Welcome to extruding to a normal. In this video, we are basically going to change the axis for extrusion for finer control. So let's hop over into Blender and play with that now. So the first thing that we can do here is we can correct my obviously deliberate mistake of this extrusion into our model. Now, fortunately, it looks like it has gone down and through the center of our model. So how do we make sure that we can pull it back out and line it up here? Well, there are a couple of ways to do that. But one of the easiest ways is once we have these
6 faces selected, they combine all as one to generate a common normal, which is actually the same as the vertex normal in the middle here. It'll be pointing upwards, so towards us. Now, down here with the 3D manipulator widget that we've played with in the past, you can change that from where it says global to a couple of other things, one of which is normal. Now, if we change that to normal, and surprise, surprise, we can't see the blue one anymore because it's pointing right at us. So the normal coming out of this vertex in the middle is facing right towards us. So if we rotate round, we can see there it is. And what we can do at this point is we can literally pull that back up, and that will be perfectly in line. So we can move it up or down as much as we want. Now, bowling balls have holes going inwards, so going out is no good. But what we can do at this point is go ahead and select the snapping tool, select the, I don't really care which one we do it to, we can just align it with a face. And this time when we move it backwards and forwards, we can hover over a particular face we want to align it with. I don't think face is actually going to be the right one in this case. I'm pretty sure that is now aligned, but I can't be 100% sure unless it's really to a vertex. Let's do vertex instead. So again, let's move it up and down, and to snapping, that is definitely in the right place now. Now, because we've moved it all the way down and brought it back again, that would have produced a series of doubles. So before we do anything else, I'm going to now push it into our model to a certain level. And that is 1 Blender unit. So let's push that in now by 1 Blender unit. So that is -1 in the Z-axis. And I'm going to turn snapping off. There we go. So if I type -1, have I lost the opportunity to do that? Yes, I have. So let's grab that and move it in the Z-axis. And remember, that will now be moving in the Z-axis that is normal, because that's what we've set. In fact, at this point, I'm just going to undo to here. So we're going to move that, not extrude in this case. The other ones we will extrude, but this has already been extruded, and it's just on top of one another again in the Z-axis by -1, and that should go inside our model, and it hasn't. You see, it's moved in the wrong Z-axis. So along here, have we got the orientation? So in the operator panel, there is orientation that's currently set to global. So because we use the shortcut keys, it's assumed something different to what's down here. So if we change orientation back to normal, it will go in, and in this case, exactly what we want, in towards the center of our sphere. That doesn't look quite the right depth, so I'm just going to increase that a little to 1.5, and because I haven't gone off of this yet, I can set that Z constraint there to -1.5. I think that will be better. So let's go and do a challenge. It's challenge time. I'd like you to create the remaining finger holes. So use the circles that we have created, extrude them along the normal Z-axis, and then set them to a depth of 1.5 Blender units. Pause the video now and give that a go. Okay guys, welcome back. Let's hop over into Blender and complete our bowling ball. Okay, so we've successfully done that bowling ball there. Let's go up to the top here, and I can see straight away we've got one thing to do to our circles. We need to inset them a little before we actually do anything else. So let's go ahead and do that straight away. We can grab them both so they inset by the same amount and inset them. It doesn't have to be much, and there we go. Now, I'm about to say something isn't possible, whereas in fact it is possible, but not with the knowledge that we've learnt so far. So you can extrude both of these faces if you change the pivot point to individual origins and have the gimbal set to normal. That would then work absolutely fine. But we're going to do it individually since we don't actually possess that knowledge just yet. So now we're ready to do this. I know the extrusion itself will not work if we try and do them both at once because it will take a normal that's between these 2 points instead of the points themselves. So we're going to have to select the faces themselves. It's selected on normal and I can just extrude, make sure we are extruding and start to push it in. Now I can see down in the lower left it says it's moving on the normal. We can see that straight away. It's done that by default, which is great. And we can set that immediately to -1.5. And there we go, that's inside our pin. So let's select these ones here as well. And it was set to normal here. So if we press E, is this also going to extrude along the normal? This is brilliant. And let's set that to -1.5. Now, there is a chance that these two will cross one another. So there we go. So a design problem with our spec straight away is that the holes themselves, these two, as they move in, are going to hit one another. But it doesn't look like the overlap is that much. So in this case, I'm going to simply pull one of these back out until they're not touching anymore. So I'm going to grab that bottom. I'm going to move it in the Z axis, but not the global Z axis. I don't want that. I want to move it on this axis here. So I'm just going to grab that instead and just pull it up ever so slightly. I can't see what I'm doing. We don't want geometry crossing. That's bad, bad, bad. And there we go. So a consideration there, if someone gives you a spec that has a fault in it, do mention it to the person as quickly as possible. I've already mentioned it to myself. Let's do the final thing now and hop into object mode and look around our model, and that looks absolutely fine. In fact, that doesn't look too far apart now. That looks absolutely fine. Right, so the final thing that we will do on this bowling ball is give it some colour. It's looking a bit bland at the moment. So let's go into our material properties and add a new material slot, create a new material, and I'm going to call it very imaginatively bowling ball. And I'm going to scroll down here on diffuse. I'm going to change that. What colour should I have it? Why not? Sort of a yellow, bright yellow colour. Great. So there we go. We've got our bowling ball all coloured in. I'm going to make sure I remember to save that as well. Very important. And that's ready to use wherever we want to use it. Now, some of you may be thinking, well, I've seen bowling balls and they're sparkly or they've got textures on them or words, etc. Don't worry about that for the moment. In the next couple of sections, we'll be going into much more detail with our models. But do remember the skills that you've learned so far, you can now go back and practice, colour in the models that you've already made and saved in your project folders. So that's great, and I will see you guys again soon. Take care. Welcome to Importing Blender Files. In this video, we'll be showing you how to import multiple Blender files into a scene. We're going to be learning the difference between append and linked, and understanding that a composited scene can exist with both types in it. So appending. So this is great when making a scene with multiple models. A note here that you have control over the model, its scale and position, and you can edit the model. So it's like taking a copy into the current Blender file. So a great example of that would be a coffee table plus 2 cups, which is just one blend file, that cup. Or indeed, you never guess it, a bowling ball plus multiple pins. So let's have a look at linked. Now, when making an object of components, so if it's one object but has multiple components in it that make up this overall object. So you do have no control over the model's position, scale, etc. And you cannot edit the model. It's done in the source file. So if you need to adjust anything when you link an object into your scene, you have to change the actual blend file itself and then reopen the file and it'll come through. A great example there would be like an anatomical model where you've got a bone layout and then you want to add muscles on top, where you could do the muscles in a separate Blender file and move them in, etc., etc., into the right position. Let's explore this now in Blender. So here we are with the bowling ball we've created. Now the first thing I will want to do is go over into the outliner here and just do a bit of tidying up, because we've still got items in here we don't need, and we're working on this icosphere. Well, let's name that straight away bowling ball if you haven't done already. If you have, well done. Cube, well, we're not using that anymore, so I'm going to delete that, and the same with sphere. So we've got a much more simplified model here. Now I'm going to go to File and Save, and I'm just going to make sure that's saved in the right place for me. There we go, so that is saved. Now we're going to open a brand new Blender file. And the first thing we're going to do is we're just going to set up a little stage for this to work on. So I'm going to delete the cube that we had there, and then I'm going to add a mesh, and I'm just going to add a plane. That's quite small at the moment, so I'm just going to boost that up, let's say 16 on the radius. So it's a nice floor plane for our stuff to work on there. So there we go. Let's now import one of those models. So let's import the bowling ball first of all. So to do that, you'll want to go to File, and we've got our two options down here. We've got Link and Append. Now in this case, if we link all of this stuff in, it will appear at the origin in the middle of our screen, because that's where the model was produced, and it will be of no use to us. So we are going to be using Append. So you simply go to File, Append, or you can use Shift and F1, and then go find your file. So mine is in my bowling assets folder. Now you obviously will have set up a project folder and be working from that, so go grab your bowling ball from there. Once you've clicked on bowling ball, it's not opened it up, it's opened up this new hierarchy. So a .blend file is a container file of lots of other Blender objects, settings, etc., as you can see down there. And we want object. So click on object, and there's our bowling ball. And if we hadn't renamed it, that would have said icosphere, and there would have been cube and UV sphere, or just sphere down here as well. So we want bowling ball. You can double click that, or just click it and then click Append from library, up to you. And there's the bowling ball in our scene. Now it's come in on the origin, and I'm just going to shift it over now, because the next thing I'm going to ask you to do is import the pin. So it's challenge time. It's time to import the bowling pin. So go ahead now and import the pin, and do make sure that your bowling ball and pin are the same relative scale. So pause the video now and go give that a go. Okay guys, welcome back. Let's hop straight on over into Blender. Right, so let's get this pin into our scene. So I'm going to go to File, Append. Now I'm already here, I'm just going to click up one because I know, oh, and again, and there's my bowling pin. So now that's in our, there, object and pin, append to library. So we can see here that the ball and the pin are at different scales. In fact, I think the bowling ball itself, because of my mistake earlier, is just over twice the size. Instead of making it a diameter of 2.16, I made it a radius of 2.6. So my mistake, but we'll go ahead and correct that now. Now we have two options. If we knew we were going to use this ball over and over and over again, then what we'd want to do is edit the initial blend file of the bowling ball itself. Otherwise, we could edit it in the scene as well. So because we've appended it, we could just multiply it by a scale factor to bring it back to the right mount. But I'm going to do things quote-unquote properly, because there's a good chance that I'll want to use this bowling ball at some other point in either this course or in a game I'm producing or something else. And I don't want to have to keep remembering to rescale it. So I'm going to save my file now. And I'm going to call this Bowling Alley. Why not? It's descriptive of what we're doing. And just save that file. Great. Now I'm now going to go back to my original bowling ball. There we go. And we're going to have to change the scaling on this. Now, I've already done the maths, and the basic scale here, because, I don't want calendar, I want calculator. We have a bowling ball that is 2.6 in diameter. It should have been in radius. So we can already sort of guess we're going to be multiplying it by something like 0.5 to half the size. But the proper radius it should have been is diameter was 2.16, and this is going to be 1.08. So we need to do 1.08, which is our size we want it to be, and the size it currently is 2.6, so I'm going to divide that by 2.6. And we can see there I need to scale this by a factor of 0.415. I'm not going to worry about the other bits and bobs there, so 415. Okay, so scale with the S key. Oh, let's select it first. Scale with the S key. Excellent. And then we need to just go 0.415. Enter. And we're going to save that now. So that's overwritten the bowling ball, and it's now the right relative size to the other model. Now, I'm going to go File. Definitely saved it. I'm going to go Open and go to our bowling alley. And you'll notice that this hasn't changed, and that's because it's appended and not linked. So I'm just going to delete that from our scene. And I'm going to go File, Append, go up, and go to our bowling ball, and go to Object, go to Bowling Ball, and Append from Library. Now, if you got the scaling right the first time, unlike me, then you wouldn't have to go through that. But there are going to be times when you mess up your scale at some point. Don't worry. In this case, the bowling ball was so simple, we could almost go back and model it again. But that's not always going to be the case. You're going to come across you spent hours and hours doing something and it's 1.5 times too big or something silly like that. Don't worry, you can always scale it back down. This is a 3D modeling package. You can do anything. Okay, so that's our scene basically set up there. We need to do a few more things, and we'll do that in the next lecture. Now, go ahead and share in the discussions how you got on, and I will see you in the next lecture. Take care. Welcome to the final scene. So, it's challenge time straight away. You need to make 10 pins correctly spaced. Now, if you're unsure about the spacing that they need to be, use reference material for the correct spacing. And remember, you may be working at a scale. We're working in general at 10 times at the moment, so 30 centimeters would be 3 Blender units. You're going to have to create 9 additional pins in our scene. So you can do that in a number of ways. I'll let you choose how you go about that. A couple of ways I can think of. You could just duplicate and move. You could use the array modifier. Up to you. Go ahead and try that. Name your objects in the outliner, and you can use the reference material for the numbering of the pins, for instance. And go crazy, make it exciting. So manipulate those pins, make them look like they've been smashed into by the ball. And I want to see your final composition. Please share in the discussions. It would be great. So pause the video now and go and give that a go. So here we are back in Blender. Let's go ahead and multiply our pin. Right, so the first thing we need to consider is how many of these do we want? We want 9 of them, and there are several ways we could go. We could literally just duplicate 9 of them and manually position them. Or we could use an array modifier and go through that way. I'm going to use a combination of them both. So I'm going to create 4 of them first by going to the array modifier. So with our pin selected, I'm going to go to our wrench. I'm going to go to add modifier and go to array. And I want 4 of them, so I'm going to put the count at 4. Now, before we used relative offset, I'm going to use constant offset this time. So it's not a spacing of pins, it's actually a distance between. And I think they're about 12 inches, which is about 30 centimeters. I'm not going to do the exact number to keep things easy for our calculations here. So that would transpire up, because we're working at a 10 times scale, to 3 Blender units. So there we go, with a constant offset of x equaling 3, we get our 4 pins ready. And I'm going to apply that straight away. So now that that is applied, the next thing we need to do is create our additional pins. So I'm simply going to duplicate this new mesh that we've made. So there we go. I'm going to lock it to the XY axis by holding down Shift and Z. So now it's not going to fall through the floor or end up in the air. Now we need to do some positioning here, and I know we're going to be moving this one forward by 3 Blender units and then moving across by half of that, so 1.5. So we're moving along here, and if we look down at our little axis, that is positive Y to go that way, and then positive X. So I'm just going to go and move that. I could do it in the operator panel. That would be far easier because then I don't need to worry about where it is. So X needs to be 1.5. There we go. And Y needs to be 3. Excellent. So that's in the right position. Yes, we've got an odd one over here, but we're just going to delete that in a few moments. And I'm going to do exactly the same process again. I'm going to duplicate it. Job done. Oh, I've positioned it in a very weird place, but it's okay because in this operator panel, we've got X, Y, and Z there. So I can set the Z back to 0. The Y again, so it's forward by 3. So I almost got that right there. But the X needs to be 1.5 again. And then I'm not going to produce another 4 or another 3 additional ones here. I'm just going to go into our meshes here. Our objects, and I'm going to separate them out. So I do need to be in edit mode to do that. So we'll select one of these first of all, select this first group, and we're going to separate all of these. So let's hop over into edit mode, and then P to separate. And then we need to choose, not by selection like we've done before, but by loose parts. So all of these bits of geometry are not connected to one another. So first thing, before I do that, I do need to highlight the entire mesh. There we go. Otherwise, we'll be separating that little window that was selected at the front. So P, separate by loose parts. And you can see it's generated a few more meshes. And we'll go ahead and name those in a moment. And let's go on to this section here. Hop into edit mode. Select all of our model. Separate by loose parts, and we'll do it once more on this top one. So we're going to simply go into edit mode, select everything, press P, separate by loose parts. So again, we're here, and I'm going to use one of these. So let's leave there. I'm going to use that one there and actually move it to the forefront here for us. So I'm going to use that. I'm going to move it in the X by minus 4.5, I think. Yep, brilliant. That's in the middle. Then I just need to move it again in the Y by 3. So there we go. We've got that sorted. There are pins laid out. I'm going to select these two and delete them. Brilliant. So we should have a count of 10 pins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Brilliant. Now the reason why I didn't just count the ones on the screen is because if there was a pin on top of a pin, you wouldn't necessarily see it. But that's not the case in here. The outliner shows 10 pins, but they're not named correctly. So let's go get the naming convention and see how we're supposed to name them. Well, so we didn't have to go far here to see our layout and what the numbers are. So that's great. Now we've got that for reference, we can hop straight back over into Blender and name our pins. Right, so let's whiz around here. I feel like this is the way they should be labeled. So it's going to, this one's going to be pin 1, and it's blatantly not at the moment. And because we're going up to 10, I'm going to leave the dot in there and call it pin 01. That was 2, 3, 4, 5, 6, 7, 8, 9, 10. So a very arduous thing. I may indeed speed up the video if I can't bore you all with waffle. So I'm just going through here really quickly, renaming all of our pins to the appropriate names, making sure that I'm referencing them correctly. Okay, so with all of our pins labeled now, we can start being crazy with it. So let's move this bowling ball into a much more dynamic position. Let's move this over here. Let's move it right into the middle of our pins. And now let's move these pins with a bit of artistic license. So I'm just going to grab a pin, rotate it round slightly, lift it up, have some fun with it. This one, of course, because the balls come in, would be somewhere over here. So shift it over there, rotate it round. Brilliant. And we can just play with this to our heart's content until we've got something looking relatively dynamic and exciting. In fact, I think that's getting... Well, these two look too similar, I think. Well, I suppose they would be if they were falling in the same direction. But let's just rotate this one round a bit more there and move it there. So it's a bit more dynamic. That's great. This one here... In fact, let's go a bit crazy. Let's just lift that one right up out of here. So it's going absolutely flying. That's starting to look really good. And let's put this one having a slight wobble. You see it's going into the floor there. We do need to watch that so we can select it and just pull it back up again. Of course, because these things are moving, they can be slightly off of the ground. That's absolutely fine. This one's obviously been impacted by the ball because the ball's inside it. So we can move that one over here and just, again, play with it. Be more dynamic. The ball hasn't reached here yet, so that's absolutely fine. And then we can look at it from various angles, and there we go. I think that's a pretty dynamic scene. How did you guys get on? Please share in the discussions, and I'll see you again soon.
Hey guys, congratulations on getting to the end of section 3. You've learned more about manipulating meshes, you've even learned how to create multiple levels of detail, and had your very first go with materials. What next for them, Mikey?
Well, I'd like you to go ahead and make your pin unique, and remember to share it with us in the discussions. And go back now, you've got a pyramid and several other models that we've gone through. Have some fun with those and use the skills you've already learnt and apply those to the models.
Absolutely, so well done on getting this far. Why not dive straight into the start of the next section right now, just to break that resistance to starting and get the momentum. See you soon.
See you there.